Hey guys, this is the lesson for geometry class for Thursday, the 28th of January, and it's composition of transformations. So basically, all that composition of transformations is doing two or more transformations in a row to the same point. All right, so you're going to start with a point, do a transformation to it, and then do another transformation to that image. Okay, so like for example, you might take a point, reflect it over a line to get a new point, and then take that point and just translate it a certain number of units to a different point. Okay, that would be an example of a transformation, a composition of transformations. You start with one point, call it A, then you reflect it across a line to A prime, and then you move that over here to A double prime. Okay, so you're basically doing like a series of transformations. Okay, it could be a series of transformations that involve any number of transformations, and it can involve any of the four different transformations, which are translations, reflections, rotations, or dilations. Okay, it can be any combination of those things. Now, the notation that they use to indicate a composition of transformations is a little circle. Like, so for example, this might be something like a reflection across line L. Let's say this is line L right here. A reflection across line L followed by, I know it's a little weird, I'm writing from right to left, but that's the way we do it, a translation of AB. Okay, so if that's the transformation we're doing of the point XY, you're going to work from right to left. Okay, so it's a little weird. I know that's not how we read and stuff, but that's just the way that this is done. This is the you do this one first, and this is the one that you do second. Okay, and it definitely matters. In most situations, you'll get a different image if you do them in a different order. I mean, just look at this problem here. Like if I were to, instead of reflecting and then translating, if I were to translate it first and then reflect it, I would definitely get a different image point, right? If I were to translate the same amount and then reflect over the same line, but in the opposite order, I get a different point in the end than I should get. Okay? So that's it. The general rules for the transformations don't change. Remember, those rules are for translation, you're going to add or subtract. For a reflection, you're going to graph it. For a rotation, you're also going to graph it. And for a dilation, you're going to multiply. Right? Those are the rules. You add or subtract to translate, you multiply by the scale factor to dilate, and for reflections or rotations, you graph it. All right, so let's do a couple examples. Suppose we have here's some graph paper right here. Suppose I have something like they're asking me to do a reflection across y equals x composed with a translation of 4, -5 of -1, -4. Okay, so I'm starting with the point 1, -1, -4. That's over here. That's where I'm starting. Let's call that point A. Okay, so according to our rules, the first thing we're going to do is the translation part. Okay, well, remember, to get that image, I just add to the x value and add to the y value. I'm going to add 4 plus -1, which is 3. And I'm going to add 5 plus -4. Or -5 plus -4 is -9. So that gets me to 3, -9. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I wanted to, I could have done that graphically. Remember, I could have started at this point and just moved 4 to the right and 5 down. I'd get the same spot, right? 4 to the right, 5 down. It gets me to the same point. Okay, so you can do it that way. That's okay. But I'm just doing it the easiest way, which to me is adding and subtracting. Now I need to do a reflection across y equals x of that point. So remember, for reflections, I want to graph it. Well, I've already started that. The first thing I want to do is I want to graph the line y equals x. Okay, so the line y equals x is just the main diagonal. It has a slope of 1 and a y-intercept of 0. This is the line y equals x right here, right? So all I want to do is I just want to start at the point 3, -9, which is right here, go directly to the line of reflection perpendicularly, which is a slope of -1. This is 1, 2, 3, 4, 5, 6 diagonal lines. And then go across 1, 2, 3, 4, 5, 6 diagonal lines. And that's where I end up. So the overall image of this right there, its coordinates are -9, +3. And that's the overall answer of this question. Okay, this is a double prime, if you want to call it that. But the overall answer is -9, 3. Right, so there's no difference between what we're doing now and what we did before. We're just doing 2 of them at once, okay, in succession. You're going to do it to one point, and then you're going to do it to its image, do something else to its image. Let's try another one. What if I have something like the dilation scale factor 2 composed with rotation 90 degrees of the point -2, 3. So same thing. I'm going to start with -2, 3. Okay, and I'm going to rotate it 90 degrees. Well, let's think about that. That means that I have to take my paper and rotate it 90 degrees. So if I take this, remember 90 degrees is 90 degrees counterclockwise, which is this direction, right? So if I take that point A and rotate it 90 degrees counterclockwise, this point now is at -3, -2, right? I move to the left, or 3 to the left, 2 down, -3, -2. So I'm just going to put my paper back the way it was. -3, -2 is here. Okay, that's where it ends up, A prime. This is -3, -2. Now I just want to do a dilation scale factor 2 to that. Remember, that's just multiply. So I end up getting -6, -4. And if I plot that on my paper, -6, -4, it's just as I think it should be. It ends up being a point that's twice as far away from the origin as it was before. And that's the overall answer right there. Okay. One more example. You can also do a composition of transformations where you're doing the same type of transformation each time. That's perfectly fine, right? So like, for example, what if I have something like a reflection across y equals 2 composed with a reflection across x equals 1 of the point 5, 3. Okay, again, I'm going to do this one first. I'm going to start with 5, 3. And I'm going to reflect across x equals 1. Well, remember, x equals 1 is a vertical line passing through the x-axis at 1. So it's this line right here. That's x equals 1. So if I reflect across that line, I'm going to go straight to the line horizontally That's 4 units. And then across it, same distance, 4 units. I end up right there. That's A prime. All right. So this is the point, -3, +3. And now I just need to do a reflection across y equals 2 of that point. Well, y equals 2, that's a horizontal line passing through the y-axis at 2. That's this line. Y equals 2. So if I reflect over that line, go straight to the line vertically and then across it the same distance, you end up here, A double prime. And that's the answer, -3, 1. Okay, so that's all there is to it. When you're doing a composition of transformations, you always work from right to left, and the basic rules of each transformation don't change. You're just doing 2 things in a row. All right, enjoy, have a great day, and I'll see you soon.